Okay, question number 4. This one's got an grotty bit towards the end, which I get the impression is something they might do a bit more of. So we'll have a look at it. Antibiotics in the bloodstream, it comes from a dosage and modeled by a particular formula, e to the minus 0.2t, based upon what the original amount is. That's fairly common. It's a common decay. The reason for E in there is by changing the value of D and the value of the 0.2, you can actually model any exponential curve. Any exponential that is some value x is proportional to a value to the power of x, sorry, y is proportional to a. So they can all be stretched and moved vertically and horizontally to turn them into a single exponential graph. If some of you have seen Matt Parker, he talks about there is only one true parabola. Any parabola, by stretching, flipping, translating, is a version of this single parabola. The same thing goes for an exponent. So often you'll see exponents given in the exponential being given in terms of e because of the nice properties of e. So let's look through the question. X is the amount of antibiotics in the bloodstream, D is the amount given at the start of the time, and T is the amount in the antibiotics after the time that last dose was given. So we're going to give 15 milligrams, use the model to find the amount of antibiotic in the stream 4 hours after the dose was given. So this one is basically a straight substitution. So X in 4 hours is the amount of given, 15 milligrams, dose in milligrams, so the answer is in milligrams, e to the minus 0.2 and times 4. Type it into your calculator and rearrange. Where's my calculator gone? Where's calculator, sorry. I've actually got a Casio calculator, so I'll use that. There's my Casio calculator, FX32. Let's get them out of the way. So first value 15 multiplied by shift D to the power of -2, 0.2, sorry. It doesn't matter in this whether or not you use that minus or that minus. This is a property of the numbers theoretically. And we wanted T to be 4. And we get an answer. There is now 6.7374. 39, 3 significant figures, 3 decimal places will give me 0.40. The accuracy they wanted. 3 decimal places, there you go. Answer given to 3 decimal places as requested. Worth remembering in a minute that we can also use this explanation. We need this bit in there in a bit. Second dose is given 15 milligrams, is given 5 hours afterwards. Show the total amount of antibiotic in the stream. 2 hours after the second dose is 13.754. So part B, first part we need is how much do we need from, how much is left over from exercise 1, from the first stuff. So the first lot after 5 hours is 15 e to the minus 0.2 times 5, which is 15 e to the minus 1. And when we calculate that amount, Again, using the calculator. So I'm just going to edit my previous calculation. Now it's got 5 in it there. We had 5.5 5.518 milligrams to 3 decimal places. Then we added, for the second stuff, we're now adding this in. So we've got 15 plus the 5.518 is the amount in the bloodstream at the start of my new time. And we would like to know how much is there at the end of 2. So it's e to the minus 0.2 times 2. Put it into the calculator again. So now we've got 20. 20.518. Add the two amounts together because that's how much there is at that start time. It's decaying at the same rate. Just because it's been in there older doesn't mean that it's disappearing any quicker. Well, you might say over a very long period of time there would be an accuracy problem, as it might get weaker a lot stronger quicker. 4 milligrams to 3 decimal places, and that's what we were asked to show. So what we were asked to show, quote demonstratum. The last part is the reason why I've been writing this in this weird way and realizing that this is that number. Show that this can be represented in the form of time is equal to a log b plus e to the over e, and we want to know the amount of time for 7.5 milligrams. So we're using this equation. We're using equation 2. So we want to know when 7.5 is equal to, now the temptation is to say 15. That's what they're banking on, is you put in just 15 in there, but let's put in the full version for xt, which is 15 plus 5. I think I'm going to have to reboot this in a minute. 0.518 e to the minus 0.2 times the time t needed. Oh yeah, running, I don't need to. I've got a few Chrome browsers. I'm just taking some Chrome browsers out because they're slowing up my computer. Now we need to rearrange it into a form where we can do the logs and to get the t. But notice there's a funny thing going on inside this expression. So what we needed to think about is, first of all, that e there is one of these e's. And then what we can do is we can actually take this 15e to the minus 1 and replace it in that expression. So we've got 15 plus 15e to the minus 1. That puts my e in the denominator. E to the minus 0.2t. Rearrange the expression. So we've now got, so we've got 7.5. Let's do the logs first. Log first. .5 divided by 15 plus 15 over e is equal to e to the minus 0.2 times t. Take the logs of both sides. So ln of 7.5 divided by 15 plus 15 over e is equal to minus 0.2 times t. Divide through by 0.2. So use the log rule for division. So we've got ln 7.5 minus ln 15 plus 15 over e. All of that divided by minus 0.2 gives me my t expression. And when we rearrange it, the minus flips this round, so we've now got our ln of 15 plus 15 over e. To be divided by, swap those round, so this is now a division sign on the inside. So this divides by 7.5, flip, and then reversing this, putting back into a single log, and we've got 1/5 is t. Simplify through, and we get 1/5 of ln of 2 plus 2 over e is my value t. So a equals 0.2 and b equals 2. And a and b are integers to be determined. They've been determined. 0.2. So this part here, this two steps, some people might be slightly wondering what was happening. We're cancelling the minuses. So we get ln of 15 plus 15e minus ln of 7.5, or divided by 0.2. The log there on the top gives me the log here. So we recombined it into the division rule. Okay, by switching the signs. And that's how that whole question gets done. Give me that and give me